of the gravity small. Previously, we have known that the escape velocity on the surface of Earth is, that is V is equal to under root twice G capital M by R. That is equation 1. Again, we have to know that acceleration due to gravity on the surface of Earth is, that is small g is equal to G capital M by R square. Then simplify this equation, that is Vm is equal to G R square, that is equation 2. Then we have to put the value of equation 2 in equation 1, that is Ve is equal to under root twice G R square divided by R. Then R get cancelled and Ve is equal to under root twice Gr. That is equation 3. That equation 3 is the escape velocity of the satellite on the surface of Earth in terms of the gravity small g. Then again we have to see that effect of the acceleration, effect of the density of Earth on the escape velocity of the satellite on the surface of Earth. We know that Earth is a solid sphere, so that volume of Earth is, that is 4 by 3 pi r cube, that is equation 4. Then we have to also know the mass of Earth, that is equal to volume of Earth into density, that is mass, which is denoted by capital M, volume denoted by V, and density, which is denoted by rho. Then we have to also put the value of this volume of Earth in equations 5, that is capital M is equal to 4 by 3 pi r cube rho, and that is equation 6. Then value of equation 6, which is putting in the equation, that is Ve, that is Ve is equal to under root, that is twice capital G, the value of M is 4 by 3 pi r cube rho divided by R. Where R get cancelled and remaining thing is, that is Ve is equal to under root, that is 8 G pi R and rho. Then R square, then we have to take out that value of R and 8 into outside the square root. Outside the square root, that is twice R under root, that is twice G pi R rho. That is the escape velocity of the satellite on the surface of Earth in terms of the density rho. That is the escape velocity of the satellite on the surface of Earth in terms of density rho and in terms of the gravity small g. Then we have to see that escape velocity of the satellite at height h h. Then again consider the satellite of mass small m, which is revolving around the Earth at height h with critical velocity vc. Let us capital R be the mass of Earth and capital M be the capital R be the radius of Earth and capital M be the mass of the Earth. Then that satellite which is revolving around the Earth at height h, then we know that binding energy of satellite at height h is d E is equal to g capital M small m upon twice r plus h. That is equation 1. But we have to know that satellite which is revolving at height h, which is overcome from the rest condition from the surface of Earth, then there is a necessity of the kinetic energy to overcome from its rest condition at a height h. Then kinetic energy of satellite is Ke is equal to 1/2 m v square. That is equation second. When that satellite which is revolving at height h, then there is a necessity of that centripetal force, and due to that centripetal force, that satellite which is revolving around the Earth in a stable orbit, for that centripetal force which is provided by that binding energy, so that is Ke is equal to that is binding energy Be. That is equation 3. Then from equations that is 1, 2 and 3 we get that is 1/2 Ke small m v square is equal to g capital M small m divided by twice r plus h, where small m get cancelled, 1/2 get cancelled, and then ve square is equal to under root g capital M by r plus h. Then taking square root on both sides, that is VE is equal to under root that is g capital M divided by r plus h, and that is equation 4. That equation 4 is that escape velocity of that satellite at height h. Then again we have to see that effect of that acceleration due to gravity gh on the escape velocity. We know that the equation for escape velocity at height h, v is equal to under root capital G capital M upon r plus h. But acceleration due to gravity at h at h, that is g h is equal to g capital M upon r plus h brackets. Then simplify this for gm is equal to gh in bracket r plus m bracket square, and that is equation 5. Then from equation that is 4 and 5 we get that is VE is equal to under root that is GH R plus H bracket square upon R plus H, where R plus H and 1 R plus H get cancelled, and remaining thing is that is VE is equal to under root GH R plus H, that is the escape velocity of the satellite at a height h, that is equation 6. But we know that Earth is a solid sphere, then volume of Earth is V is equal to 4 by 3 pi r cube, that is equation 7. But mass of the Earth, mass is equal to volume into density, that is equation 8. From equations that is 7 and 8 we get mass capital M is equal to volume 4 by 3 pi r cube into density, that is rho, that is the mass of the Earth. Then this mass of the Earth which is put in the equation, that is V is equal to under root capital G capital M upon R plus H, that is V is equal to under root the value of capital G is capital G, then mass 4 by 3 pi r cube rho upon R plus H. Then these equations also simplify, that is twice R in bracket, that is G pi R rho upon thrice R plus H, and that is equation 10. And this equation is the equation for the escape velocity of the satellite at the height h in terms of that density rho. After that, after the escape velocity, we have to see the next article, that is weightlessness. Then that weightlessness, which is divided into the three terms. First, weight of the body, then any body, how to feel the weight, and any body which does not feel the weight. That weight of the body means the earth gravitational force which is active on the body, then that body which feel the weight. That is the weight of the body, amount of earth gravitational force which is acted on the body is known as the weight of the body. Then that body or any persons which are in the that plane is in the satellite and feeling the weightlessness. When that body is in the satellite or the aeroplane, then that persons which are feeling the weightlessness. That weightlessness means the amount of earth gravitational force which is acting on the floor of this plane or the satellite. That earth gravitational force does not directly acted on that person which is known as the astronaut. That astronaut does not feeling the weight. When any body which feel the weight means the earth gravitational force which is acted on the any body, then it react any types of the reaction against that earth gravitational force. That is happens according to the Newton's third law of motion. That is action and reactions are equal and opposite. But when that person or astronaut are in the satellite, then that person does not any types of the reaction on against that earth gravitational force. But that floor of satellite which react the reactions against that earth gravitational force, so that persons and satellite which are in the same centripetal oscillations, and due to that person does not react any types of the reactions and it feel the weightlessness. That is the term weightlessness.